combines kind of two things we talked about last chapter: slope and limits.
Is there graphing involved?
No, no graph.
Oh my word.
No,
All I care about things.
Okay,
She says that.
that's true.
You say that too. Brenna.
I promise.
Where's Brenna?
Alright, so a quick review. We're gonna do stuff like this throughout our process, and we've done something kind of like this in the past. So whenever we had evaluation, I gave you a function, something like this, and then I asked you to find something with this inside of it. What did we do with stuff that's inside of F?
Factor
We would substitution. Yep. So whenever you see something inside parentheses next to F, remember that is a substitution. So we would take whatever's in there and substitute it in for all the x's. So we have 1 plus h squared plus 1 plus h. And then when you have this squared, we can't just distribute a square. Remember? What did the square ask us to do?
Distribute it.
We can't distribute a square.
You gotta rewrite it.
Yeah, we have to take it times itself. Because remember, whenever you take 4 squared, that means 4 times 4. Whenever you take 3 squared, 3 times 3. So whenever you have 1 plus h squared, it's telling you to take 1 plus h times 1 plus h. So we have to multiply that out with FOIL. Okay? So whenever you see something squared like this, it is telling you to take it times itself. So we have to take 1 times 1, which is 1. 1 times h, which is h. H times 1, which is h. H times h. What's h times h? H squared. And then we still have the rest of the problem, so I'm just going to write that down here. And then to finally simplify, what can we do?
You do like put them all together, but like
Finally, ship.
this is a lot of things because
Okay. So you have h, h. How many h's? 3. Yep. So we have our h squared first, because we write stuff in order. So then we have 3 h's. And then we have 1 and a 1. 2.
Okay,
I'm so confused.
I just figured it out.
I think it's the weird. It's like the weird numbers, like the weird amounts.
I mean, it would be like the same thing if you made that it like f of 3 and like you plug it in, except now it's 1 plus h.
Yeah.
Didn't we do this?
Yeah.
I kind of got confused, but it's okay. We'll get there.
Okay, so like I said, we're gonna have to do this within our process. We're gonna have to take stuff and substitute it into x, stuff that's not just numbers. Okay? So when you substitute an expression in there, and then when you have a square, so you take it times itself, so then you have to FOIL, and then you combine like terms at the end. Okay? So we'll come back to that. We'll use this in a little bit.
Oh, they're ones. I thought they were L's.
No, no, no.
Taking
Whoa.
time is so confused. I was literally like, why?
Why
Do
did
we
you
have
add
L's and
1
H's?
plus h?
Because we have to put it in for this other x.
That's funny.
Okay.
Yep.
I was thinking it was the other way
Yeah,
around.
so this all came
Yep.
from this FOIL, and this came from the other x.
I get it.
That makes so much more sense now. Don't mind me. Just being stupid.
The tangent line stuff is a no for me.
Alright. So now, I've looked at this graph before. So when we were doing estimating slope, what we were finding is slope of the secant line, because you had to have 2 points, and then we picked several points around it, so we found several little slopes for each secant line. But really what we want is this tangent line, because that gives you the most accurate slope of that point on that graph. So what we're going to do, like I said, is instead of using estimation with slope, we're actually going to use kind of our slope formula, and now we're going to combine it with the limit. Okay? Now, usually when I did this without a note packet, there were several slides here where I didn't really have you write stuff, because what I like to do is kind of show you where this formula comes from. So that way, instead of just giving you the formula like I do, usually, that way you can kind of see where we go from our regular slope formula and combine it with the limit. Okay? So I'm going to talk through some of this kind of fast because, like I said, I'm just kind of show you where it all comes from, and then ultimately it's leading us to a new slope formula that uses a limit, so we don't have to estimate slope anymore. We can find it using that new limit formula. Okay, so you're good.
This isn't even my brain.
Alright,
It's a little sausage.
so like I said, I'm gonna go through this really fast. Alright,
You're going fast?
yeah, 'cause I'm just showing you where it comes from. You won't have to do any of this yourself.
This is just like the backstory.
Yeah, this is the backstory of our formula.
This is a
Okay, in
program.
history class.
So, usually with slope, you need 2 points, right? You need x1, y1, x2, y2. So here, what we're doing is we're trying to find a slope at a specific spot on a curve, okay? So, 1 point is A, and then the y value we're going to call f of A, because the way we get the A value, remember when we were estimating slope, we took that x value I gave you and plugged it into the function to get y, okay? So that's what we're going to call our first point A, f of A. Our second point is going to be just a slight distance away from that point. We're going to try to get it as close as possible because that will give us the best slope that we can get. So we're just doing it a little bit later. So we're going to do a plus h to show that we're just a little bit away from that original A value, okay, or the original x value. So then that point is A plus h for x. And then again, the way we get the y value is we plug that into the second function. So our second point we're going to call A plus h and f of A plus h. Okay, so then we use our original slope formula, and we're going to plug in these 2 random arbitrary points where we're trying to find a slope at a specific x value, but only try to use 1 point and then 1 point that's really, really close to it, as close as we can get to, maybe even where we can't even necessarily measure it. So we're calling that point A plus h. So we plug that in, we subtract our y's. So our first one y is f of A plus h, the other y is f of A. So that's the top part. There's really not much we can do with that because it all has f's and everything in there. Okay. The bottom is we subtract our our x values, A plus h minus A. Okay. So if you look at this, some people started to notice, but A plus h minus A, what happens to my a's?
It goes away.
It goes away, so now I just have h on the bottom. Okay? So then they started thinking, okay, what if h was 0? Because that means that this distance away is just kind of right on top of each other, but that won't really work because we can't divide by 0. So then what they decided to do is take this new slope formula with those 2 arbitrary points and combine it with a limit, because we really want h to be 0, because we want the distance of the second point to be as close as we can get to get the best slope possible, because we really want it just at that 1 point, because we know as we picked other points around it, we got varying slopes, so we had to average it to get kind of a good slope for that point. So if we can get something that was approaching 0, but not quite 0, we could then find a good slope for that without having to find 6 or 7 other different slopes to average them. So the important thing now is we're going to use this new slope formula to find the slope of the tangent line. So that's why there's a little sub thing next to m. So that helps us find the slope of a tangent line for a curve. So we can use a limit where so our h is always going to be approaching 0. And so then our goal is, because no matter what our f of x is, we won't be able to substitute 0 into our limits right away. Because again, remember with limits, our goal is to solve the limit, is to substitute this number into whatever we have here. But we can't do that right away because h is on the bottom, we can't divide by 0. So we're going to have to do some simplifying for the top parts, which I'll show you that in an example here in a second, to try to get rid of the h on the bottom so that we can eventually plug 0 in for h. So that's our goal, okay, is to eventually use this slope formula. And again, right now it just looks like a weird formula. We don't know what to do with it. I'll show you what to do with it here in a second. But again, our goal is to evaluate the limit, to be able to substitute 0 into h, which like I said, with the original way it's written, you can't do that right away, but through some simplifying that I'm going to show you, we will actually be able to evaluate the limit for 0 and find an exact slope instead of estimating the slope. Okay, so this is our important formula. That was that star.
That was not a star.
No. It's kind of like my cursive S, like combined with something, I don't know what it was. There it is. Okay. You ready to do an example?
We're gonna do it anyway.
Okay. So then not only do we find a slope, a lot of times we write an equation for it. So remember back in chapter 0, we talked about writing an equation using point slope form. So what we're going to do is work real hard to find the slope, and then we'll have a point to plug in for x1, y1, and so we'll have an equation for this line that just touches this curve at that one point. Okay, so that's kind of like the second curve. So those are the A and B. So part A, find the slope. Part B, write the equation. And every once in a while, you won't have to do part B, you'll just have to do part A where you just have to find the slope. But I'll show, usually with my examples, I show both. So here, when you're asked to find an equation of a tangent line, we're going to do both parts, part A, part B. I have them labeled 1 and 2. So we're going to find slope using our new slope formula first. Then we're going to substitute it into our point slope form to write our equation. So for part 2 or part B, we're going to use that formula. For part A, we're going to use our new formula, slope. And you don't have to use the sub tan all the time. I'm just going to write n, which is the limit as h approaches 0 of f of a plus h minus f of a over h. Make that legible. So those are the two formulas we're going to use. One is brand new. One we've used before. We're just using it in this case. So we're going to do part 1 first. And I'm actually going to switch. We can call it A and B instead. Because I like calling it A and B later. Okay. So for part A, we're going to find the slope. So what we need is a function and some sort of A value, which is really an X value. Okay. So this, I'll talk about a little bit more about that in a second. So we have an A and we have a function. Okay. So we need a function because that's what we have here. We need an A value to plug into our A here and here. And again, H is 0, okay? So eventually we want to put 0 into H, but we can't do that right away because we're going to get 0 on the bottom. So we're going to save H 0 until the very end, okay? I'm going to do a little bit of setup first, and then we'll start doing our process. So we're going to have a function. Our A value here is 1. So we have 1 plus H minus f of 1 over H. Okay? So that's what our formula looks like right now. So again, I gave you an A value. So that's where the 1 came from. That's a 1. And I put it into my slope formula. Okay. Everybody with me so far? Yes. Okay. So now, when I saw this before, if I said f of 1 plus h, what is that asking you to do with 1 plus h? Substitute it, okay? So whenever you see this top part of the formula, it's actually asking you to do 2 substitutions, okay? So you're going to take 1 plus h and substitute it into whatever function I've given you. So I have to give you a function. So we're going to do that substitution. So we're going to put 1 plus h into that. So we're going to do all that, simplify it, everything. And it's also asking you to do another substitution. So eventually we're also going to put 1 in there, okay? So when you see the top part of the new slope formula, it's asking you to substitute 2 different things into my function. We're going to do that separately. Everybody ready? So I'm going to start with the 1 plus h. It's telling us to put that into my x in f. Okay. Now, I usually like to do both substitutions at once and then kind of work together. Is that okay, or do you want me to just do this one, then go back and do the other one? I'm just going to do that. Okay. So I'm going to put brackets around around it just to show that separation. Okay, so we still have the minus. That comes from the formula. That doesn't come from the substitution. So now my other substitution is just telling you to take 1 and do what with it?
Square it.
Put it into my function. Okay, so I have everything set up so that way I can kind of simplify all at once. And then it's still all over h.
So you're always going to be subtracting.
So I just have everything set up. I haven't simplified anything yet, but it's everyone following from what I started with to now what I have in brackets and all that stuff. Okay, so now what we really have to do is simplify the top. Because again, remember our ultimate goal is to solve the limit. Our ultimate goal is to be able to substitute 0 in for h, which we can't still right now because we can't get 0 on the bottom. So we need to try to simplify the stuff on top to hopefully maybe cancel out that h. So then we can put 0 in later. Okay? So I have 1 plus h squared. What's that asking me to do with 1 plus h? Foil it. Yep, take it times itself. Okay, so I'm going to go ahead and multiply it out. Don't forget that we also have a minus 5 here that I'll put in a second. So we have 1 times 1, which is 1. 1 times h, h. H times 1, h. H times h, h squared. And then I'll go ahead and put the minus 5 next to it from the other part of the function. So now I'm going to simplify that. Yep, so h squared plus 2 h's and then minus 4. Okay. So that's for this part. Try not to rewrite it several times. Okay, so now I'm going to try to, I'm squeezing it at the bottom of the page, I'm sorry. So now we need to do our other substitution and we're going to subtract it behind whatever I got just there. Okay, is everyone good with what I just did?
Yes.
Okay, so the minus always here. So now I'm going to go and do this substitution. So what's 1 squared?
1.
1. And then what's 1 minus 5?
Negative 4.
Negative 4. So down here I'm going to put negative 4. I have to keep both negatives. The subtraction from the formula. And then I got negative 4 when I solved out my number.
I have a question.
Yep.
Do you subtract like each section, or do you mush it all together and then?
So you combine all this together first.
Yes.
And then subtract this from just this.
Okay, so it's not like all mushed together. Okay.
Okay. So now we have one more round of simplifying. So we have h squared plus 2h minus 4 minus negative 4. What's going to happen if I take negative 4 minus negative 4? 0. I'm going to get 0. Okay? So we have h squared plus 2h over h. Okay, so I've gotten rid of that number. And I will tell you, I don't know what I'm saying. That should happen every single time. So you should be able to cancel out the h because, or cancel out the 4 or whatever number is here because we're still trying to put 0 in for h. If I put 0 in for h, can I do it now? No. So I've still got 0 on the bottom. But now if you look at what I have on top, what do both of those have in common? An h. So we had a type of factoring that we had. If we can take out a common thing, we can take out a common h on top. So an h. So if I take an h out of h squared, I have an h left. And I have taken h out of 2h. What do I have left here? 2. So then what can I do with my h's?
Cancel them out.
Cancel them out. So now can I put 0 in for h?
Equals 2. Yeah, that's just part 1.
Yep. Part 2 is very
I
very
also
short.
ran out of room.
Okay, so there is our slope. So I put 0 in for h. I kind of did a shorthand thing there at the end. I hope that was okay.
What'd you do?
Technically, I should have rewritten this as 0 plus 2 and 2.
Oh,
Okay. But again, your goal is always to take 0 and put it into h. And you won't be able to do that until the very end.
I have a question.
Okay? Yes.
There is no possible easier, less ridiculous way to do this.
Not right now.
Not right now.
But eventually,
There's a
Oh,
solution.
that's all the room we need for part 2?
Yep.
Okay.
Alright. So we have our slope now. So we have this part of our formula. So we have y where it crosses over a little bit, that a value is always your x1 value. Okay? So whatever you're given as a, that's your x1, so that's what I'm going to put in for my x1 in this part of the formula. So to get the y1, again, how would we find the y that's attached to this x?
You plug the
Plug
x
it in.
into there.
Yeah, so we're going to plug it into the x. Where have we already done that?
Right there.
Right there.
Right there. So what did we
Therefore,
get? A negative 4. So we have the point 1, negative 4. Okay? And like I said, if you forgot that we did that before, you can just plug it in real quick anyway. But again, we've already done y1. Whatever we get with our second substitution is always the y1. So we have minus 4 here. And now we just need to simplify. So that's going to make plus 4. So we have y plus 4. Distribute the 2 equals 2x minus 2. Subtract 4. So y equals 2x minus 6.
This is way too much.
It's actually not as bad as
This sounds really
okay. I really
Well,
kind of
Like, I
all
hope we
the
only have like
problems.
2
That's
problems
fine.
on our homework.
Yeah.
Because
1, 2, 3, 4, 5, 6, 7, 8.
some of them aren't this. I promise. All right, let's do it.
do another one.
looks like Mr. Sharp's version of the I have a question. What area of workforce is this?
Whenever you're trying to find
Okay.
slope under a curve, so anytime you're working with velocity or changing,
It looks great.
like a quantity over the other, so whenever
So like engineering.
Then I'm
Physics
not
is
going to be an
engineering.
engineer. Yep.
Physics? I know, I'm bad.
Physics has a lot of
What is organic chemistry? I never do it.
Alright.
Well, we have to take it.
I feel like Mark really got
I was telling my mom.
Are you going to think
I was like, Mom, what if I married just like a
kind of
Yeah.
rethink
Alright.
the whole thing?
So here, my a value is 3. Now, you don't necessarily have to show this part every single time, but I like to show where we're starting to where we're gonna go. So our a is negative 3 plus h for our top part in the first half, and then we have negative 3 here, and it's over h. Okay, so that's putting it into the formula. So now we're gonna have to do our 2 substitutions. So we're gonna take negative 3 plus h and put it into both x's. So this time it has 2 different x's. So you're gonna put it into both. Does that make sense? Now I'm going to do my other substitution. What are we gonna do with the negative 3? Substitute it, so negative 3 squared minus 7 times.
Hold up.
Okay.
I am behind.
So I like to set up both substitutions, and then that way I can just do work. Okay, now here's the other thing I like to do is remember this thing is all over h.
Where'd you get
Okay.
7?
Oh, question. Thanks. All over.
Hold up.
Okay.
Why'd you put static? I don't know. Can you wait?
I'm
know.
lost.
Can
I
you
Also lost.
Where'd you get
can you
7?
explain what you put in each thing?
You're plugging it into the
Plug it in for both x's.
Okay, but what is what?
So we took negative 3 plus h.
Yeah.
And plugged it in for both of these x's. So negative 3 plus h squared minus 7 times negative 3 plus h.
Okay.
minus.
What?
I don't understand where you got this. Why'd you put the 7 in there?
You
put it in the problem.
You're still in the original page.
Yeah.
I like an L.
But it's a 7x, not just a 7.
Plugging it into
So you have to substitute.
So that's part of the first one. Okay.
Yeah. So that's why I put brackets behind around it. So this is part of the first substitution, and this is the
Okay,
second.
that makes sense.
Now I'm going to not put the all over h part until later, because again we can't do anything with it right now. So that way I don't have to rewrite around it. Is that okay?
Yep.
So don't forget it's still there. I'll put it back in a second. So this negative 3 plus h squared. What's that asking us to do with negative 3 plus h?
Violet?
Yeah.
I don't know what's wrong with my accent today, but it's happening.
So negative 3 times negative 3.
9.
9. Negative 3 times h. 13.
3h.
Negative 3h. Negative h times negative 3.
Negative 3h.
Negative 3h. H times h.
H squared.
H squared. There's a pattern there, so sometimes you get good at it. What do I need to do with this negative 7? Distribute it. Negative 7 times negative 3.
Negative 21. 21.
Yep, 21. Negative 7 times h.
Negative 7h.
Okay.
Squared plus, wait, what is that? Plus 2.
21.
That literally looks like 21, but I way overthought that because of all the letters.
So I have h squared. I have negative. What is happening?
Yeah.
I
This
have
is the
h
one thing you
squared
understand.
minus 6h. I have 9 and 21. That's 30. So wait.
Should we get 2 days to work on this? I will.
13h. And then plus 3.
I'm so excited for Thanksgiving.
Oh, wait. Oh, I'm just gonna forget all of this over Thanksgiving break.
Oh.
Alright.
Bastard.
So there's the first substitution. So I can't go back. Forget to go back and do this one. So what's negative 3 squared?
9.
9.
I'm lost.
Where did I get what? So I combine all my like terms. So I have an h squared. Negative 3, negative 3.
Plus
negative
21.
Negative 31.
13.
Is that 13? I thought it was like a
Okay.
B. I'm like, where did a B come
I
from?
know where we're at.
I'm sorry, I have that. Okay. 9,
I'm sorry.
21, 30. Alright. So, negative 3 squared is 9. What's negative 7 times negative 21? 21. So when I add those together,
Plus 30.
okay?
Minus 30.
So then that's what I subtract. What's going to happen to my numbers?
They're gonna cancel
That
out.
should happen every single time.
What if it doesn't though?
So go back and check your work.
Okay.
I'll just make sure it cancels out,
Okay.
actually.
Yeah.
If it
Now
doesn't,
I-
it will.
Delete the number.
So now, I still can't put 0 in for h. But what can I do at the top?
Distribute.
Yep, take out h. So I have h minus 13 over h. Then what happens? So then what do I put in for h?
Negative 13. 0.
0. So m is going to equal
Negative 13.
negative 13. So there's part a.
I'm slow. This seems like less writing work than it did the first time.
Yeah.
I'm gonna get at it. Time just seems to fly. Where do you get the Y?
I forgot.
Alright, so that's my x1. So I have x minus negative 3. But you can switch to positive. Where do I get my y1?
I forgot.
You plug it in.
Plug it in. Okay, where have I already done that?
I don't know.
30.
It's going to be 30, yep. And again, if you've forgotten that, negative 3 squared is 9. Negative 7 times negative 3 is 21. And you add those together to get 30. So then we write our equation.
I don't know what negative 13 times 3 is.
Same.
So...
Different stuff.
Yeah. So 3 times 1 is 3.
Minus
3 times 9 is, or 3 times 3 is 9. 39.
I don't know how you learned it, but I never learned that in my life.
So take 3 times 1 is 3. 3 times 3 is 9.
No way, I never learned that before.
So then I have y minus 30 equals negative 13x, and then that becomes
Y.
positive to start with, and then turns back to negative. So then what do I need to do?
Plus 30.
Plus 30. So
I
my
know this
equation-
now. Y equals negative 13 x minus 9. You're welcome.
Is that it? That's your done?
Nice.
I can't.
Can we
Tried.
stop for the day?
I'm trying.
My brain.
I just get confused right here. Right there.
Yeah, so like when we
Where
didn't
should
make a
we
note for this condensed.
Maybe
What
I
is
would-
velocity?
Okay, velocity's just slow.
There's another one.
Oh my word.
Okay, whenever you have to find velocity is slow.
Mitch.
Okay?
Can you put it in half? Can you like cut it in half?
What?
Like make this another section?
Alright, so whenever asked to find velocity, you're asking to find slope. Okay? So we can actually use the same slope formula. I just use some different variables. You can use f and a and m if you want. But find velocity is a slope of a specific point on a curve. Okay, so that's what we're gonna do. And
You get a
really,
history lesson on this one too?
No,
Good.
I think that confused me more.
Yeah.
I think my brain is.
Oh
God,
No,
We're
please, this is giving me physics PTSD.
Yeah, this is seriously physics. And it makes me want to.
I can't.
I'm bad at
Well, they still know physics.
alright,
I
okay.
don't know.
Alright, suppose that the height of a falling object seconds after it's being dropped is at 64 given this position function. Alright,
I'm gonna cry.
you're okay. So we have a position function. S of t equals 64 minus 16t squared. We're gonna find the instantaneous velocity. Whenever you see this phrase, instantaneous velocity, that's how you find the slope. Okay? So all you have to do is part 1 or part A. So we're just finding the slope and we have found the velocity. Does that make sense? So you don't not worry about writing an equation. You're just worried about finding velocity, which is finding slope.
I took off my shirt in the changing room, but I left it there. I should take it for sure.
Alright, now
When I was doing
do you want me to switch and use S, or do you want me to continue to use F?
Please use that.
Okay.
Keep things the same.
So, and the only reason why I wrote it differently on the last page is because a lot of times velocity position functions are labeled S of t. It's all the same thing. I could switch that to F and X, and you would get the same equation.
Cool.
So then the t is the a value. So I give you the time, which is your a value. So we're gonna do 2 plus h minus f of 2 over h.
Then you gotta plug it all in.
Now we're substituting.
I have
Yep.
never been so lost in my life.
I enjoy it.
Do you plug it into the ST?
I like feeling lost. Makes me feel just the.
So it's 64 minus negative 16, then the
Yep.
2 plus h.
So here it's just a t instead of x. So we're gonna take this 2 plus h and plug it into the t.
64.
That's an A squared. And then you do the same thing.
Squared bracket done. Whoa. Wait.
Taylor, did you get the right thing?
Here, ready?
Mm-mm.
Nope. give me
Whoa,
a
they
second, give me a second.
started.
Whoa, you wrote that fast. I was just thinking about it.
Alright, and
Minus 64 minus 16 with the 2 in the parentheses for some reason. Then you have all these crazy freaking brackets.
She's telling you how she's put up the phone.
Okay, wait, time out.
Well,
What does
gonna
F
cry.
stand for?
That's coming from me.
Whatever equation you have.
Why do I not
So-
understand this?
So instead of labeling it F, I label S of t, but you can switch it to F of t.
imagine if we learned something in physics and then we came here and we knew what we were doing.
Question.
well, now you can learn it.
No,
here.
I would first
So
learn it here
is
and H.
Then go to physics.
64
That's
minus
what I would do.
16
Yeah, but-
squared.
Then we would have
So no, it's
that would be
it's
nice.
t. So you substitute that.
The Miss Field.
Yeah, no, T is this guy. Apparently, what Steve What? did was
H
get.
is always 0.
Yeah.
Mrs.
So
Sharp's
I
not
should
for
have
his
put 0
physics
in
grade.
But we can't do that right away because we have the zero H at the
Yeah.
bottom. So now we just need to simplify this stuff.
So we do
Sharp can help with that.
2 plus H.
Why the plus?
But where are you getting?
Oh, some lady at college
Actually, hold on. I think
that
there's
called me.
So F
Yeah,
I'm not
F is the function.
is that. So we put that's
just
where the
lost.
F's are.
Maybe someone told you too. I didn't know things.
Leona, you got a 31. Shut up.
What?
I'm not taught that.
Where? What's the T? What T?
T, it's just X.
The T is
T?
boiling.
She just switched letters. It's an X.
It's just an X. You substitute it for X. Or take it for
T
Y.
is just a variable.
I don't understand where it's coming from. Where do we write it?
I
Lost H.
So
X.
H
That's
is
fine.
so high.
Yeah.
What? You just substitute it in.
I don't
But
know why.
64 minus 16.
But you can't subtract that because it's attached to T. You have to plug that in, we'll solve that out, then we'll
I'm gonna solve this one. You tell that to Clara.
I don't know why I don't understand that.
Using variables. So when we have 2 plus h squared, what's that telling you to do? Boil it. So we're gonna take 2 plus h times 2 plus h. So 2 times 2 is 4. 2 times h is 2h. H times 2 is 2h. H times h is h squared. This one we have a unique thing. We don't have a number in front of it. So what are we gonna do with the 16?
Multiply it all.
And it is
16
negative.
times 4. It's 4. 4 times 6 is 24. So is that 124?
Yep.
Oh. I
So
don't think I did your trick
16
right.
times 4 is 64. Okay, what I like to do is instead of multiplying it to both of these 2 h's, how many h's do I have? 4. And so I'm just gonna take 16 times 4h. Is that okay?
64 H's?
Yep. Negative 64 h's.
Negative. Why negative?
But I'm distributing a negative 16.
Oh.
Then we have negative 16 h squared. Okay?
Minus 64. Minus 64H.
So 64.
Okay? So now
So you got put 64 on it. Yep.
we have to solve out the other parts. So what's 2 squared?
4.
Four.
Negative 64.
Yep. So then we have 64 minus 64.
That's a 0.
0. Okay. Would you necessarily have to put minus 0 there? No. I did that for consistency. So what's going to happen to my 64s?
Cancel.
Cancel. So I have negative 64h minus 16h squared over h.
Wait, do we need to like rewrite that?
Yep.
Or no?
So you got the H, right?
Yep. So now what do both of these have in common? An h. Okay, you can take out a number, but don't worry about that. So you have negative 64 minus 16h. What do we do with the h's?
Cancel out.
Cancel what do we put in for h?
64 is ending for 64.
Yep.
But you put a 0.
So then since it's velocity, we're going to do a label.
Wait, why is it negative? That's my bad.
If we're doing velocity, it's feet per
Square.
second. Okay? If it's acceleration, it's feet per second squared. Velocity is just feet per second.
So
Oh my.
How do you know that? Did you say?
It's whatever units divided by time.
Michaela, we know this from fifth.
we know this. That's a strong statement.
You know the
because we know
labels.
this.
Michaela's learning it.
No, the labels. When we have to do acceleration.
Well, I probably could have figured the labels
So
out.
you
on
don't
this
have to do the second part?
So
It's
they're
just,
just explain velocity. Just
I
Oh,
should
velocity.
understand. That is what I like.
Huh?
I understand this stuff.
Now we're just done. And now it's just homework.
Yep, now we go home.
Yep. No.
Now I go cry.
I don't understand.
No, we only have our